Hello, in this part of gravitation, you will learn about weightlessness, gravitational field, and gravitational potential energy. Let's start with weightlessness. When a body presses against a supporting surface, the supporting surface exerts a force of reaction on him. This force of reaction produces the feeling of weight in the body. If somehow the force of reaction becomes zero, the apparent weight of the body becomes zero. A body is said to be in a state of weightlessness when the reaction of the supporting surface is zero or its apparent weight is zero. A body can be in the state of weightlessness when it is falling freely in a lift as shown. We have already done this part in the laws of motion also. And this one is a situation of weightlessness. Inside a spacecraft, at null points in space and at the center of Earth. The situations are shown. Gravitational field. Two bodies attract each other by gravitational force even if they are not in direct contact. This interaction is called action at a distance. It can be best explained in the terms of concept of field. According to the field concept, the space surrounding a material body within which its gravitational force of attraction can be experienced is called its gravitational field. The Earth is surrounded by a gravitational field. Any body brought in this field experiences a force of attraction towards the center of Earth. Intensity of gravitational field is the gravitational field due to a given mass is the force experienced by a unit mass placed at that point, provided the presence of unit mass doesn't disturb the original gravitational field. You know that according to the Newton's law of gravitation, the force of attraction between the two objects is F is equals to G into mass of the earth into mass of object divided by distance square between them. And if you will divide by the mass of object, you will get G capital M upon R square. And this one is the intensity of gravitational field denoted by capital E. And you know that this Gm upon R square is also the acceleration due to gravity. At R is equals to infinity, E will become 0. Thus, gravitational field intensity decreases as distance R increases and becomes 0 at infinity. Gravitational potential energy. When two bodies are placed close to one another, they interact through the gravitational force. Due to this, they possess mutual gravitational potential energy. Gravitation potential energy of a body is the energy associated with it due to its position in the gravitational field of another body and is measured by the amount of work done in bringing a body from infinity to a given point in the gravitational field of another. Expression for gravitation potential energy. Consider the Earth particle system in which particle of mass is raised at a height h above the Earth's surface, and the change in gravitation potential energy will be mgh, as we have already calculated in the work chapter also. And for the expression of this one, consider a body of mass m situated at point A at a distance r1 from Earth's center, and it is moved from point A to B at distance r2 as shown in the diagram. If at any instant body is at point C where OC is x and the gravitational force on the body at C will be given by gme into small m, the mass of the object to be taken, divided by x square. Therefore, work done in moving body from C to B will be dw is equals to minus f dx. Put the value of f here. Now, change in potential energy is given by du equals to minus dw, and the increase in potential energy in bringing the body from r1 to r2 will be integration of dw within the limits r1 to r2, and on solving it you will get delta u as gme into m into 1 by r1 minus 1 by r2, and delta u, you know that it is the potential energy at r2 minus potential energy at r1 position. And if we choose potential energy at infinity be 0, then moving from distance r to infinity, you will get the value of gme into m upon r, because u infinity will be 0. So, u at any distance r will be given by minus gme into m upon r. Therefore, the gravitational potential energy of Earth mass system is minus g into capital M, means mass of Earth, into small m, the mass of object, divided by distance between Earth and body. We have proof for Earth mass system, but this one is true for any two mass system. Therefore, in general, in place of me and m, you can write m1 and m2. Gravitation potential energy for the system of particles. The total potential energy will be equals to sum of the energies for all possible pairs of its constituent particles. And this one is an example of superposition principle again, that the net u will be equals to u1 plus u2 plus u3